Hi guys, today we're going to be looking at postulates, definitions, and theorems. Our objective is to practice working with these postulates, definitions, and theorems that we've learned about, and we're going to use them with many two-column proofs. So proofs are just a way of making statements and then giving a reason for being able to make them. So below are some of the definitions and postulates that we've learned so far. If you want to take a minute, pause the video, you can write these down again, even though you're already in your notes from before, okay? So let's look at example 1. Example 1 starts off with a statement that's been given to us. It says that angle 1 and angle 2 are complementary, and that was given to us. Now the second statement says that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Well, how did I know this? Well, I knew this because I knew the definition of complementary. Back up here, the definition of complementary says two angles whose sum is 90 degrees. So the first angle plus the second angle is equal to 90 degrees. So my reason for being able to make that statement is the definition that I knew of complementary angles. So the definition of complementary angles is what allows us to make this statement. I can say the measure of angle 1 plus the measure of angle 2 is 90 degrees because of the definition of complementary angles. And that's all. Alright, let's look at number 2. Number 2 says A is between B and C, and that's what's given to us. So it asks us to make a statement after that. And the reason for our statement is the segment addition postulate. So I need to go back up to the segment addition postulate and see what it says. It says if B is between A and C, then A plus AB plus BC is equal to AC. So let's use that in our statement. Our statement says A is between B and C. So if I were to draw a line, that means A is between B and C. So the segment addition postulate would say for our picture that BA plus AC is equal to BC. And that's just using this segment addition postulate. Part plus part is equal to whole. Part plus part is equal to whole. Alright, let's look at the last one. The statement that we're given is that the measure of angle ABC is equal to the measure of angle DEF, and that's what's given to us. The next statement says that because of this, the angle of ABC is congruent to the angle of DEF. Well, how did I jump from measures being equal to congruent? Well, let's look up here at our definitions, and it was probably this definition of congruence, which says that it's something that has the same size or measure. In this case, in our example 3, these two things had the same measure, so I could say that those angles were congruent. And I say that because of the definition of congruence.